What is negative feedback in control systems explained? Imagine trying to keep a bicycle balanced while riding. If you lean too far to one side, you automatically make adjustments to stay upright. That's similar to how negative feedback works in control systems. It's a way to keep things steady and predictable. In control systems, negative feedback takes a part of the system's output and feeds it back to the input. This feedback is then subtracted from the original input. The goal is to reduce the difference between what you want and what you actually get. This difference is called the error signal. When the system detects a deviation, it makes corrections to bring the output closer to the target. For example, in an electrical amplifier, a small part of the output voltage is fed back to the inverting input. If the output voltage increases, the feedback signal acts to decrease the input difference. This keeps the output voltage stable and prevents it from going too high or too low. It's like a thermostat that turns the heat off when the room gets too warm. Negative feedback has some key features. The feedback signal is out of phase with the input, meaning it is inverted. This subtraction helps stabilize the system. It also reduces the overall gain but improves how well the system responds to changes. It makes the system less sensitive to noise or disturbances. When external factors try to change the output, negative feedback adjusts the input to counteract those changes. Mathematically, the system's gain with negative feedback is calculated by dividing the open-loop gain by 1 plus the product of the feedback factor and the open-loop gain. This formula shows how feedback influences the system's behavior. In real-world control systems, negative feedback is used everywhere. Voltage regulators, temperature controllers, and audio amplifiers all relying on it to keep their output steady. Inside a control system, there's usually a summing point where the feedback signal is subtracted from the input. The resulting error signal drives the system to make adjustments. Over time, the system works to minimize this error, keeping the output close to the desired value. In short, negative feedback is a simple but powerful technique. It feeds a portion of the output back into the input in an inverted way. This process corrects deviations, stabilizes the system, and makes it more reliable. It's a fundamental part of how control systems keep everything running smoothly.